Okay, let us solve this question. The question is from computer networks topic, which is asked in GATE previous year, 2014 GATE question paper. The question is, an IP router implementing classless interdomain routing (CIDR) receives a packet with address 131.23.151.76. The router's routing table has the following entries. The entries are given. The identifier of the output interface on which this packet will be forwarded is. So in the question, the routing table is given. The routing table consists of IP address of the network and the subnet mask and the interface number. Here all the three fields are given. The subnet masks are also given, but they are given indirectly. We have to calculate the subnet mask here. And what the router does is, the router adds the subnet mask with the IP address of the received packet, and then it finds the network ID. Once the network ID is found, it forwards the packet to the respective network with the network ID found. So what we have to do is, first of all we should calculate the subnet masks of all these networks. So what is the definition of the subnet mask? The subnet mask represents all ones in its network ID part and all zeros in the host ID part. So here in the first field it is given that uh, the network the network has an IP address with this IP address, and the number of network ID bits are 12. So so we have to put 12 ones in the network ID part, and remaining all are host bits. That is 20 host bits are present in the subnet mask, and 12 ones are present in the 12 network bits are present in the subnet mask. So the subnet mask is 12 ones, 1 2 3 4 5 6 7 8 dot 1 2 3 4, and remaining all are zeros. 1 2 3 4 1, this is 0. The all zeros the value is 0, and all 0 the value is 0. What is the value of this? 255 dot, this is 240 dot 0 dot 0. So the subnet mask of 1 is this 255.240.0.0, and the subnet mask of 2, that is interface 3. So let us represent this way. So subnet mask for interface 3 is this, and the subnet mask for interface 5 is 14 ones in the network ID part, means 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 0 0 dot 0 dot 0. This equals to 255 dot 252 dot 0 dot 0. This is interface 5's subnet mask, and the subnet mask for interface 2 is 16 bits, 16 ones in the network, 16 network bits. So we have to replace all those network bits by 1 to get the subnet mask. So 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 0 dot 0 0. This equals to 255 dot 255 dot 0 dot 0. And similarly for 1, this is for 2. For interface 1 there are 15 network ID bits, so the subnet mask would be 255 dot 254 dot 0 dot 0. So now we found out the subnet mask for all the interfaces. What we have to do is, we have to add the uh, IP address of the received packet with all these subnet masks, and we have to so that we can get, after ANDing we will get the network ID of the receiver network ID of the receiver device, receiver network. So there may be a chance that if we AND with this, if we AND with, if we AND the IP address of the received packet with one or more than, so now if we AND the IP address of the received packet with the first subnet mask, that is subnet mask of interface 3, we will get, so if we AND any number with 255, that is 8 ones, we will get the same number, so it is 13. And now we have to AND the 23 with 240, that is represented in binary as in 8 bits like this, and the 223 is 23 is represented like this. So if we AND 0 1 0 0 1 0, so if we AND this 13 dot 0 0 0 1 0 0 0 0 dot 0 dot 0, so this equals to 13 dot 16 dot 0 dot 0, and this matches with the network ID of the interface 3. So this is matched, and next we have to see with the next interface, that is interface 5. And now if we AND the IP address with the second subnet mask, we'll get like this. So the only difference that makes is the second byte, that is 252. So we represented 252 in 8 bits and 23 in 8 bits. Next, after ANDing these bits, 0 1 0 0 1 0 0 and so on, 1 1 1 1 1 1 1, so the value of this is 20. So the network ID came out to be 13.20.0.0, but the network ID given here is 28.0.0, so this is not matching. So the packet does not belongs to this network, so this is not matching. And next we have to see for the interface 2, and in interface 2 the second byte contains 255, that is all one. So the result after ANDing will be the second byte in the IP address itself, that is 23. So network ID came out to be 13.23.0.0, but the given network ID is 13.19.0.0. So this packet doesn't belong to this network also, so this is not matched. So now we will check for third last one, that is interface number 1. When we AND with the interface when we AND with the interface 1's subnet mask, that is the interface 1 subnet mask contains 254 in its second byte. So if we AND 23 bits second 254, we will get 22. So we came out with the network ID of 13.22.0.0, and this also matches with the network ID of the given routing table. So this is matching. So we have two matches in the given routing table. So what will routing table do is, it will find the network with maximum number of highest number of network ID bits. So among these two, the highest number of network ID bits is in the last network, that is interface 1. So router chooses this network and sends the packet to this interface 1. So the correct answer is interface 1. So output, the blank should be filled with 1.